Section 4.1, page 3 of absolute max and min. Example 4 asks us to find the absolute max and min of a function x over x squared plus 4 on a closed interval. So this is a continuous function from 0 to 3, so we can go ahead and begin by taking the derivative. Now when I look at this function and realize I need to take a derivative, I'm going to need a quotient rule. So I will let n be the numerator whose derivative is 1, and I will let d be the denominator whose derivative is 2x. So using n prime times d minus d prime times n, I get my numerator, and then I need to write the denominator squared. So not much to clean up on the top left, and on the top right, really all I'm doing is squaring the x's. So I do have like terms. Positive 1 and negative 2 will give me negative 1x squared. So I finally have my derivative. I'm ready to find out when that derivative h prime is equal to 0. That occurs when the numerator is equal to 0. So I went ahead and added the x squared to the other side. Because I had a squared, I know I'm going to get two solutions. I'm going to take the square root of the right side and plus or minus the square root of the left side to give me plus or minus 2 equals 0. So this should have been x equals plus or minus 2. So then what ends up happening is I've got a negative 2 and a positive 2. But remember, positive 2 is outside of my given closed interval. So I will throw that out. Now I need to find when h prime does not exist. It does not exist when this denominator is equal to 0. So again, maybe I would take the square root of both sides to eliminate that exponent. The square root of 0 is plus or minus 0, but 0 is just neither positive nor negative. So now I don't have parentheses around this, so I can subtract the 4 to the other side. Again, taking the square root of the left and plus or minus the square root of the right ends up giving me plus or minus the square root of a negative, and we're not dealing with complex numbers in this class, so we do not have a critical number from the does not exist denominator equals 0 portion. So remember, my next step is to test the endpoints and my critical numbers in this original function. So I like to start with h of 0 and have my h of 3, sandwiching my critical numbers in between. I didn't have anything from the square root of a negative. Negative 2 is not in that range, but only x equals 2. So going back to this original function, not the derivative, I plug a 0 in and the math is pretty easy. I'm going to get 0 over 4, which is 0. Plug a 2 in, and because 2 squared is 4, pretty easy, 2/8, although I would simplify that to either 1/4 or possibly a decimal value. When I plug 3 in, 3 squared is 9, 9 plus 4 is 13. I may not be sure at first if 3/13 is bigger or smaller than 1/4. So this is where going towards a decimal can let you know that 1/4 is larger than 3/13, both of which are larger than 0. So 0 is actually my smallest output. My absolute min has an output of 0 that occurs when I plug 0 in. And my largest output is 1/4 that occurs when I plug 2 in. Now the only other thing to watch out for on these is don't forget you have to work with trigonometric functions often. So when I'm asked to find an absolute max and min, and my function is 6 cosine of t plus 3 sine of t squared, I know that this is continuous because both functions are continuous, and I have a closed interval. So we begin by taking the derivative. So remember, my 6 coefficient stays there. The derivative of cosine of t is negative sine of t. My 3 coefficient stays here. The derivative of sine of anything is cosine of whatever we originally had, in our case 2t, but I need to take the derivative of that 2t. So I can multiply the 2 and the 3 to get a 6 in front of my cosine of 2t. This problem does not have a denominator, so I only need to worry about when does the numerator equal 0. And so I've got my 6 sine of t and my 6 cosine of 2t that I need to set equal to 0. Now, the sine is not a problem, but when it comes to the cosine of 2t, to solve this problem, it's going to be most helpful to use the double angle formula that says the cosine of 2t is 1 minus 2 sine squared t. So I'm going to go ahead and distribute this 6 to the 1, distribute this 6 to the 2, and get a minus 12 sine t squared. Now I'm going to go ahead and rearrange these. I'm going to put the negative 12 sine squared t first. Then I'm going to put the negative 6 sine t in the middle. And I'm going to move the positive 6t last to my equation set equal to 0. I can factor a negative 6 out of every term. So 12 divided by negative 6 is positive 2. Negative 6 divided by 6 is an invisible 1 that you don't see. And negative 6 divided by 6 is negative 1. The reason we wanted to do that is if we think of this as something squared, something to the 1, and something to the none, let's replace that sign of t with an x. So I still have my negative 6 factored out, GCF, but instead of 2 times sine of t squared, I'm replacing sine of t with x, so I have x squared. Instead of plus the sine of t, I'm replacing sine of t with x, and minus 1 stays minus 1. Looking at this trinomial, if it begins with a 2x squared, then I'm going to have a trinomial where 1 begins with a 2x and 1 begins with a single x. And the only way I can get a negative 1 at the end of my trinomial is if either I had minus 1 plus 1, or it could have been plus 1 minus 1, but you want to do the math that this gives you negative x, positive 2x, to end with a middle term of positive 1x. So I had replaced sine with x. Now I need to move that sine of t back to wherever x was. This allows me to use the 0 property factor where I'm not going to set negative 6 equal to 0 because there's no variable, but I am going to take 2 sine t minus 1 and set that equal to 0, add the 1 to the right side, divide by 2, and when does the sine of t equal 1/2? Kind of like an anti-trig. This happens at 30 degrees. Although our interval was given in radians, so 30 degrees has the radian equivalent of pi over 6. And because 1/6 is 0.16, which is less than 1/2, it's in my range. Now I'm going to take the other factor, subtract the 1 over, and there's nothing to divide by. Sine is negative 1 at pi, but pi is not in our range. It is beyond the pi over 2. So this is an example where one of our roots is thrown out. So I have my endpoints of 0 and pi over 2, and my only critical number that's inside that range of pi over 6, evaluating the original function, not the derivative. So plugging them into 6 cosine of t plus 3 sine of 2t. So this is just the cosine of 0, which is 1, and the sine of 0 is 0. So this piece is gone. We just have 6 times 1, which is 6. When it comes to pi over 6, I went ahead and got out my calculator. You could have done the math to get 9 squared root of 3 over 2, but what we care about is it's 7.7, etc. And pi over 2, you could probably go ahead and do this math yourself, but we get 0. So my absolute minimum between 6, 7 something, and 0 is at 0, and this occurred when my input was pi over 2. my absolute max, which if I was asked for exact answers, I need to give the 9 square root of 3 over 2, occurred when my input was pi over 6.